Hey everybody, Mrs. Bixler here, and we are cruising through chapter 6. And now we are going to talk more about slope. Slope is something we love. We know it near and dear to our hearts. And now we're going to talk more about it. So let's say we're back at Rosie's, and I know my classes have been doing this a lot. So we've talked about when you go to a self-serve yogurt place, a lot of times they have like different pay structures. So you always walk in, you pay for your cup first. And so at Rosie's, your cup costs 1 cent, and then you pay 2 cents for every ounce that you get. And then now we have a little competitor in the game. So there's this place called 16 Handles. There's one in Stamford, I know, and there are a few in the city. And so at 16 handles, it's the same price per cup. So it's still 2 cents per ounce. But the cup is a little bit more expensive. So the cup costs 5 cents. So what I want you to do right now is I want you to pause the video and I want you first to write an equation that describes Rosie's pay structure. And then I want you to write an equation that describes 16 handles' pay structure. And then I want you to graph both of them. So remember that X is the number of ounces we put into our cup, and Y is the amount of money we pay overall. So pause the video and do it. We'll come right back. All right, we're back. So here's what I got. So I had Rosie's, which told me I had Y equals 2X plus 1. And then at 16 handles, I had Y equals 2X plus 5. The only difference here is at 16 handles, the cup is more expensive. So I want to ask you a question. Is there any way that I could pay more money if I went to Rosie's? The answer is no. So if you look at your graph right here, do you see how this red line will always stay below the blue line? In fact, the red line and the blue line are changing the same amount. That's because they have the same slope. Remember, slope is rate of change. So if they're changing the same way, then they've got the same rate of change. They have the same slope. So they're never going to intersect. All right. So now I'm going to have you pause the video again, and I want you to do two things. The first is find the slope of the line in between the two red points and the slope of the line in between the two green points. And then I want you to graph those two lines. Go. All right, we're back. So here's what I got. I got the slope of the red line is 7/3, and I got the slope of the blue line, is also 7/3. Interesting. So we got the same slope. Now, does this mean that they're the same line? No. I went ahead and I graphed my two coordinate points. So I graphed the two red ones, I graphed the two green ones. It's not the same line, right? They're two separate lines. But do you notice how these lines, similar to 16 handles and Rosie's, never intersect? So, what do we know about these lines? There's a certain name that we give these kinds of lines that never intersect. And these are what we call parallel lines. So, parallel lines are two lines that never intersect and they have equal slopes. That is a really important concept. Parallel lines have equal slopes. All right, moving on. I'm going to have you do the exact same thing. So what I want you to do first is I want you to find the slope in between the two red points and then the slope in between the two green points. And then I want you to graph both of them. Go! All right, we're back. So here's what I got. So I got the slope of the red line was still 7/3, but I got the slope of the green line was 3/-7, or -3/7. Remember, it doesn't matter where your negative is as long as there's only one of them. So what do you notice about these two lines? So are these parallel? Are they not intersecting? No, in fact, these do intersect. And more than just they cross, I could have two lines that intersect like this. And these two lines that I just drew, these would not be as special as the two lines above. The reason why these two lines are special is because they meet at a right angle. So these two lines are what we call perpendicular lines. And you see perpendicular lines a lot in like city street blocks. So New York City is a perfect example. When you hear that a city is designed in like a grid form, a lot of the times their streets will be perpendicular to each other. All right, so perpendicular lines are two lines that meet at a right angle, and they have a particular kind of slope. So if we look at these two slopes, I have 7/3 versus 3 over -7, or -3/7. So these are particular kinds of slopes, and this is what we call opposite reciprocal. Now, we've talked about reciprocal before. The reciprocal of 7/3 is 3/7. But the opposite means, see how this guy up at the top, the 7/3 is positive? That means the one on the bottom would be negative. So perpendicular lines have opposite reciprocal slopes. So let's practice for a second. I want you to pause the video here, and I want you to give me the opposite reciprocal slope of each one of the slopes on the left. All right, we're back. So remember, my line is has the slopes on the left. My lines have the slopes on the left, and my perpendicular lines have the slopes on the right. So the opposite reciprocal of 2/3 is -3/2. -5/4, the opposite reciprocal is 4/5. 1/2, the opposite reciprocal is -2. So you just flip it, right? So technically it would be -2 over 1, but we can just leave it as -2, samesies. All right, ooh, so then the opposite reciprocal of 3 would be -1/3, because remember, technically this is 3 over 1, so the reciprocal of that would be 1/3. And then last but not least, the opposite reciprocal of -5 is 1/5. Excellent. All right, so last two slides here. I want you to pause the video and answer these two questions. Go! All right, so first things first, we have a line that goes through the points 2, 8 and -3, 5. So hopefully you found the slope of that line. And the slope of that line is 3/5. Good job. So that means that I can have a parallel line. And if I have a line that's parallel to that line, it's going to have the exact same slopes. The slope of that parallel line is going to be 3/5 as well. But if I want to talk about a perpendicular line, and any perpendicular line, then that is going to be the opposite reciprocal. So hopefully you got that m equals -5/3, the opposite reciprocal of 3/5. Fabulous. This is our very last slide. So what I did here is I plotted these 2 points, so 2, 8 and -3, 5. And then I said, all right, well, I want the slope of the line that's parallel to this line. Now, I use the word the, and that's really not a good word to use because there's not just one line that's parallel to this line. I could have a line that's parallel like this, or a line that's parallel like this, or a line that's parallel like this. There are an infinite number of parallel lines. Same thing goes for my perpendicular line. So if I have a perpendicular line, all that matters is that it crosses this red line at a right angle. All that matters is that it has a slope of -5/3. It does not matter what the y-intercept is. So I have an infinite number of perpendicular lines to that red line as well. So the word the for a parallel line or the for a perpendicular line isn't good. It really should be any line that is parallel or any line that is perpendicular. All right, go ahead, jump in, try the homework. You're going to crush it, and I'll see you soon. Thanks.